Complex numbers part 2. So in the last video, we learned what an imaginary number is. We learned that the square root of any negative number simplifies now to be I. And we learned what complex numbers are. They are a plus bi, where a is our real number and the b is our imaginary number. And we learned that we must write our answers in that format for the online homework to accept it. Now that we know what those are, let us figure out what the operations on these complex numbers are. So how do we add, subtract, multiply, and divide them? So I have two examples here, first with addition and subtraction. Example 1, 8 plus 6i plus 3 plus 2i. It's almost the exact same as adding polynomials. You just add your like parts. So I add my whole numbers together, my real part, where it's 8 plus 3 gives me an 11. And you add your imaginary parts. 6i plus 2i gives me an 8i. So you just combine like terms, the same way that you did it back in polynomials. Example 2 is a subtraction, and I'll talk about that subtraction in a minute. But if we follow our PEMDAS rules, we must simplify the inside of our parentheses first. And we do that by simplifying those square roots I have circled there. So, in my first parentheses, I have 4 plus 5i, and I am subtracting 6 minus 3i. So simplify the roots individually first. Now, the way that we do this subtraction problem is that this subtraction has to go through the whole second parentheses. So the way that I do that is I distribute my negative. I change this to an addition, and I change all of my signs in my second parentheses. Again, the exact same way that we did it with polynomials. So now we combine them like terms. 4 plus a negative 6 gives me a negative 2. And 5i plus 3i gives me an 8i. It is in the form of a plus bi, so we have our final answer. So that's how we add or subtract complex numbers. We just combine like terms. Multiplication of complex numbers. This one, I have negative 1/2 I times 4 plus 6i. Again, think of it like polynomials. If I have one term multiplied by a whole group, what we do is we just distribute that through. So my negative 1/2 times 4 gives me a negative 2, and then I have my I. And last, negative 1/2 times 6 gives me a negative 3. And I have I times I, which gives me an I squared. But we must write these in the form of a plus bi. So there's something going on here, and that is with this I squared. So let's figure out what we do with that. So I'm going to move over here and remind you that square root of negative 1 is I. Well, let's do a little bit of manipulation of this. If I squared both sides of that equation, on the right I would have I squared, and on the left my square and my square root cancels out. Those are opposite operations. So we are just left with the inside of that square root, which is negative 1. So anytime we ever have an I squared, we know that that actually becomes negative 1. So we must substitute negative 1 in for all of our I squareds. So that's what I have to do over here. So I have negative 2i minus 3, and again, I squared we just learned was negative 1. So simplifying negative 3 times negative 1, that gives me a positive 3. And now it's in the form of a plus bi. I just need to rearrange it in the right order. So I have a positive 3 minus a 2i. Now we are good to go. Let's see some more multiplication on complex numbers. My example 2, I have 1 plus 2i times 1 plus 3i. If you would like, pause the video, see if you can work each of these examples on your own. Alright, example 2. I have 2 terms times 2 terms. So, treating this just like a polynomial, the word that I'm going to use is FOIL. First, I have 1 times 1, which gives me 1. Outside, I have 1 times 3i to give me a 3i. Inside, I have 1 times 2i to give me 2i. And last, 2i times 3i. 2 times 3 gives me 6, and I times I gives me I squared. To simplify this, we can combine our like terms in the middle here. 3i plus 2i does simplify to give us 5i. As well as we just learned, anytime that we have an I squared, that becomes negative 1. So, copying down the rest of the problem, I have 1 plus my 5i at the beginning, plus 6 times a negative 1. Well, I can simplify that. That gives me a minus 6. And now I can combine like terms. 1 plus a negative 6, so 1 minus 6 gives me negative 5, plus 5i. Now it's in the form of a plus bi, so we have our final answer. Example 3. The wrong way to do this problem is by distributing the square. You cannot distribute a power when you have an addition or the subtraction on the inside. The correct way to do this problem is write out what the square means. So that's 3 minus 7i times 3 minus 7i. So again, it's a 2 by 2, so you just FOIL. First, 3 times 3 gives me 9. Outside, 3 times a negative 7i gives me a negative 21i. Inside, negative 7i times 3 gives me a negative 21i. And last, negative 7 times negative 7 gives me a positive 49. And I times I gives me an I squared. Again, we know that I squared is negative 1. So this is the same thing as 49 times the negative 1, or this is the same thing as negative 49. So now I can combine my like terms. I have 9 minus 49 to give me a negative 40. And I have negative 21i minus 21i gives me a negative 42i. So, it's in the format of a plus bi, and I've got my final answer there. So we've learned how to add, subtract, and multiply. So our next operation is how do we divide complex numbers? Well, if you remember, I is a square root. So whenever you divided by square roots, or whenever you rationalize to get rid of roots in the denominator, you multiplied by the conjugate. That's going to be the same thing here. I'm going to multiply by the conjugate of the denominator. So what the conjugate is, it's the exact same thing except for it has an opposite middle sign. So in example 1, I'm going to multiply this by 4 minus 5i over 4 minus 5i. I'm going to focus on the denominator to see what happens with that first. I have a 2 by 2, so I have to FOIL. 4 times 4 gives me 16. Outside is a negative 20i. Inside is a positive 20i. And last, 5i times a negative 5i gives me a negative 25i squared. If we notice in the middle, my negative 20i and my positive 20i cancel out. That's why we multiply by the conjugate, or the opposite sign. and I squared becomes negative 1. So this is like a negative 25 times a negative 1, or this becomes a positive 25. So my denominator simplifies as 16 plus 25, and that is 41. So we have gotten rid of the i's in the denominator, which is actually what we wanted to do. In the numerator, we just do what it tells us to do. So I just need to distribute this negative 3. First, negative 3 times 4 gives me negative 12. And second, negative 3 times a negative 5i gives me a positive 15i. And I'm just going to carry that over to my second step. But to turn these in as a final answer, we must put it in the format of a plus bi. What we learned earlier, all we have to do is split that up as two separate fractions. So going up here, because I'm out of room, I have negative 12 over 41 plus 15 over 41i. And that is my final answer to problem 1. Example 2, I suggest that you pause it, try and do this one on your own. It's going to start the same way as it did last time. We multiply by the conjugate of the denominator, which in this problem is 3 plus 4i. If we do it in one place, we have to do it in the second because it has to balance itself out. So in the numerator, I have a 2 by 2. I must FOIL. So first, 6 times 3 gives me 18. Outside, 6 times 4i gives me a 24i. Inside, 5i times 3 gives me a 15i. And last, 5i times 4i gives me a 20i squared. I'll come back and I'll simplify that in a moment. In the bottom, I have a 2 by 2, so again I must FOIL. First, 3 times 3 gives me 9. Outside, I have a positive 12i. Inside, I have a negative 12i. And last, I have a negative 16i squared. To simplify both the numerator and the denominator, I'm going to be doing the same type of steps. I have i's in the middle that can combine. On my top, 24 plus 15i gives me a 39i. In the bottom, 12i and negative 12i, those cancel. That's why we do conjugates and opposite signs. Also, we know that I squared is negative 1. So here I have 20 times negative 1, which is negative 20. And on the bottom, I have negative 16 times a negative 1, which simplifies to be positive 16. So combining like terms on the top, I have my whole numbers of 18 minus 20 gives me a negative 2 plus that 39i. And on the bottom, we had 9 plus 16, which gives me a 25. Almost done. It's just not in the right format, so we just split it up. Negative 2 over 25 plus 39 over 25i. Now it's in the form of a plus bi, so we've got our answer there. Example 3 is actually easier than example 1 and example 2 because there is no addition or subtraction in the denominator. So we just have to somehow get rid of that I from the denominator and put it in the numerator. Well, we do that by just multiplying by an I. So anytime you have an I in the denominator, you just multiply both the denominator and the numerator by an I. On the top, I have negative 2i. On the bottom, I have 5, and then I times I gives me I squared. We know that I squared becomes negative 1. So this is negative 2i over 5 times negative 1 gives me negative 5. I can simplify those negatives. So that gives me the answer of 2/5 I. However, that's not in the right format because it needs to be in A plus BI form. So I fill in my void with a 0 for my A or my real part. And that is my answer to that problem there. That's where I'm going to stop this video. And the last operation that I have to talk about on complex numbers is exponents or power. So that's what I'm going to do on my last video there.